Hello dear friends, welcome to my channel. Today we are going to see concept number 2 in Arena. So let us see what's the problem. We are going to model of a simple assembly and test system. This is going to be concept number 2. So this is the diagram. Part A will be of exponential distribution. Part B with batches of 4 each in an exponential distribution of 30. There's a part A preparation area, then there's a part B preparation area, and then there's a sealer. Sealer for part A is triangular distribution 134, and sealer for part B is variable distribution of 2.5, 5.3. And if the sealer is 91% successful and it is shipped, and 9% is sent for rework, out of which 20% is scrapped and 80% is salvaged and shipped. Now let us see the problem. The above system represents the final operations of the production of two different sealed electronic units as shown in the figure. The arriving parts are cast metal cases that have already been machined to accept the electronic parts. The first units called Part A are produced in an adjacent department outside the bounds of this model, with the inter-arrival time to our model being exponentially distributed with a mean of 5. All times are in minutes. Upon arrival, they are transferred instantly to Part A preparation area, where the mating faces of the cases are machined to assure a good seal, and the part is then deburred and cleaned. The process time for the combined operation at the Part A preparation area follows a triangular distribution of 148. The part is then transferred instantly again to the sealer. The second units called Part B are produced in a different building, also outside this model's bounds, where they are held until a batch of 4 units is available. The batch is then sent to the final production area we are modeling. The time between the arrivals of successive batches of Part B to our model is exponential, with a mean of 30 minutes. Upon arrival at Part B preparation area, the batch is separated into 4 individual units, which are processed individually from here on, and the individual parts proceed instantly to Part B preparation area. The processing at Part B preparation area has the same 3 steps as at the Part A preparation area, except that the process time for the combined operations follows a triangular 3, 5, 10 distribution. The part is then sent instantly to the sealer. At the sealer operation, the electronic components are inserted, the case is assembled and sealed, and the sealed unit is tested. The total process time for these operations depend on the part type, triangular distribution of 134 for part A, and variable distribution of 2.5, 5.3 for part B. 2.5 is the scale parameter beta, and 5.3 is the shape parameter alpha. 91% of the parts pass the inspection and are transferred immediately to the shipping department. Whether a part passes is independent of whether any other parts pass. The remaining parts are transferred instantly to the rework. The time to rework parts follows an exponential distribution with a mean of 45 minutes and is independent of part type and ultimate disposition, salvaged and scrapped. Color statistics in each area on resource utilization, number in queue, time in queue, and cycle time or total time in system, separated out by shipped parts, salvage parts, or scrap part. Run the simulation for 1920 minutes. This is what we are going to see now. So let us start our arena model. We are going to save it. Let us now start modeling it. So we go to discrete processing tab, and then we are going to have the create module. Let us increase the size to 100% zoom. Next is part B. So here we are going to put part A. So part A, what it has, exponential distributed with a mean of 5. So here we are entering 5, and then this is minutes. Okay. Now this is part B. Random exponential mean of minutes, mean of 30 minutes, and it arrives in batches of 4. Okay. Next, we have to choose the assign module, not the assign attribute module. Assign module. Okay. We place assign over here, and we place assign over here. We remove this. Assign, what we are going to do in assign one is we are going to click on add. Then first one is entity type is entity 1. Okay. Then again add. Then entity picture. Here we are going to choose blue ball. Okay. Then again add. Then we are going to choose attribute. In attribute we are name is sealer time. The value is right click, build expression, random distribution, triangular, then 1, 3, 4. Okay. Now assign 1 is over. Next is assign 2. Add entity type, entity 2. Then again add entity picture. In picture we are going to choose green bar. Okay, then again add, it is going to be attribute. That we are having sealer time. Here we are going to use on build expression, random distribution, and we are going to choose variable distribution. Scale parameter beta is 2.5 and shape parameter alpha is 5.3. Click OK, OK, OK. Now we have done the assign model. Now we are going to click on the process module. Then here also process module. This we are going to remove. Okay. This we are going to name it as part A preparation. Preparation. This we are going to name as part B preparation. Okay. So part A preparation, cease delay release and resource 1. Okay. Then in time, it is going to be triangular distribution 148. Triangular distribution in minutes, and it's going to be 1, 4, 8. Okay. Part B, cease delay release and resource 2. Okay. This is going to be triangular distribution in minutes, 3, 5 and 10. Okay. Next is we have to add the sealer. Now we are going to add the sealer. Please delay this, add resource 3. Okay. Here expression minutes, we have to enter a sealer time. Okay. Then we have to use the decide module. We have to go for decisions and we have to put the decide module. So discrete dispose. Here we have to enter the name with as shipped. Okay. So how much time the decide is true is? It is given as 91% of the time. So it is 91. Click on OK. Next is we have to use false, means we have to go for another process we have to do called rework. Please delay release, add resource. It is going to be resource 3. Okay. For that, how much time it is taking is 45 minutes. It's a constant minutes 45. Okay. Sorry, it is resource 4. So resource 4. Then we have to use another decide module. So percentage of the time true is 80. So dispose. So Here we have to name it as salvage and ship. Here we have to name it as scrapped. In between, let us rearrange it. We'll, we'll remove this. So we need to record the data. So we have to add the record module. So in input output, there is a module called record. We need to add this for the statistics. We delete the connections. Okay. So in record one, what we are going to do is we are going to add count one, counter number one. Okay. Then again add time interval attribute one, tally number one. Okay. Okay. In record two, we are going to add count one, counter number two. Again add, we are going to put time interval attribute one, tally number two. Record three, we are going to add count one, counter number three. Okay. Then again add, we are going to put time interval attribute number one, tally number three. Okay. Now let us make all the connections. Okay, now let us go to the run setup. Setup, it has been told to run for 1920 minutes. So we are infinite, we are going to enter 1920 minutes. Apply, okay. Then we are going to run the simulation. Simulation has completed. Let us see the results. Enable content. So this I'll move to the bottom. So here we can see uh, so here we can see 573 has been shipped. Counter number 233 has been reworked and 7 has been scrapped. These are the results for the shipped parts, salvaged part and scrapped parts. Next, we need to see the resource utilization. Resource 1 utilization is 81%. Resource 2 utilization is 70%. Resource 3 utilization is 81%. And resource 4 utilization is 94%. Next, we have number in queue. Now, part A in queue is 1.8. Part B in queue is 3.7. Rework queue is 1.4. So these are the data which has been collected. Thank you for watching.